Welcome everybody to the last sort of content-oriented computer science tutorial. So this week should be finishing up the Python unit exam number 2, and that's got 2 parts, just like the first one. The first part is more theory-based, theory-oriented, and the second part is practical again. This time for the practical, instead of having 4 required smaller programs, it's 2 programs. You have a choice. Only do one. If you do 2, if you choose to do both and submit them both, I'll take the higher mark of the 2 as your grade for that practical portion. It is the same rules apply as the first exam. It is open book, but it's not collaborative. You're allowed to practice your skills and whatnot in PyScripter, and you're allowed to do some external research, but obviously no collaboration with any of your peers, and no copy and paste from any websites. If you do any external research, it should be with the purpose of refining your understanding of how to complete the skill and why it works that way, and then use your own code, obviously, to complete the questions. Read the questions over carefully, because there's oftentimes keywords in the questions that'll let you know what needs to be done, or give you a little hint on how it needs to be done. For instance, if I include the word splicing, if we're talking about a list or a string, make sure you use the splicing method with the square brackets and index numbers, etc. And if we're doing a loop and I say use a step value, make sure that you use a step value. So little things like that. I mean, just like any other exam, make sure that you're reading things over carefully and that you're completing everything to the best of your ability. And then you got time to check it over, so make sure you check it over and catch any little mistakes or syntax errors or anything like that. So I figured the best thing I could do for you today is probably just continue sort of going through the review. Please note that I did have material up. I did have a review session that covers all of this stuff posted from last year, I guess, last school year, the last quarter of the last school year. Nothing's changed since then. So hopefully you've been watching those videos if you've started the exam or been attempting the exam, because it covers basically all the same stuff that I'm going to do in here today. But I'll just go through a couple more examples, and if it helps, that's great. And if it's something you already knew or you'd already gone over in one of those review videos, then that's fine as well. All right, so are there any questions before we get going? I'll just give you a second here. And don't forget, I'm always available via email to answer any of your questions, or maybe help you move forward with an assignment that's giving you some trouble. So never hesitate to contact me, but obviously sooner than later is better, because anything I get after Friday at noon, I just don't have time to mark it and include it in your report card with your final mark and comments. So tackle this stuff early if you feel like you're a little bit behind, and do your best to put the effort in, and I wish you the best of luck. So I'm gonna move through these pretty quickly, because like I said, there's lots of more in-depth review material on the other videos and presentations that I've posted. So this is going to be reasonably quick, and it's just picking up from where I left off in the last live session. So we're talking about an if statement here. So if in range, if in, and that the range should be on a separate line, sorry. So monitor went out for a second here. Hold on. Some monitor difficulties here, just fixing that up. The electronic crackling I hear is probably not a good sign. All right, so here we go. I actually believe I may have gone over this one before, but this might be a review even from the last session I did. Let's just say I've got a text here and I've got a sentence. You can use if in order to check if something, either a character string or a number or an item, is in a list or in a string. So this is going to be an easy way of just checking. So for instance, I can have an if statement saying if the word is, make sure it's in quotes there, in S, because S is my string, print is in the string. So and the else would be obviously this word is printed, I guess. Print is this word is not in the string. So if I were to run this little program here, we'll just say, I'll comment this out because I'm going to pass that. Toggle comment. Source code comment. So I'm just checking, is the word is in S? So seeing that S is this is a sentence, it should print out is in the string. And it does. If I'm trying to find something that doesn't exist, in this case, I'm going to put a capital I because case matters. It should give me the other message that is this word is not in the string. And it's a subtle change, but it is important. When I ask it to check for a capital IS, that's what it's checking for. It's not checking for every single possible capitalized version of the string. It's looking for exactly what you want it to. So you got to be careful about things like that. And I told you it works for lists as well, and it does. So I'm just going to make a list, and I'll put some different data types in there. I'll put Boolean. I'll put another float in there. Remember, you can have whatever you want in a list. So now I can check a list as well. So if I want to check if, let's check if, I put 6.7 in there twice, but it doesn't really matter. If 6.7 is in S, print this. Print it's in the string. Whoops. It's in the list. It's not a string anymore. Okay. And put this there. Right. It'll say it's in the list because 6.7 is in that list. It's in there twice, but it is definitely in there. If I check and see if 5 is in there, 5's in there as well. If I check to see if 4 is in there, it's not in the list because there's no 4 on the list, and should work for Boolean too. If true in S, it's in the list because I've got a Boolean true. So I've got all the different data types we've used: integer, float, string, and Boolean. And you can see you can just use an if-in statement to check if something is indeed in either a string or in a list. It works in dictionaries too. I didn't include the dictionary example, but if you had a dictionary and you checked if a value is in if a value is in a list, it'll check that as well. I believe it just checks the value, not the key, but there is another command to check the key if you really want to get into that much detail. All right, so I'll move on here to range statements. Okay, now usually we'd use range statements if we are wanting something to count up or count down, and if you know how many times you need to repeat something. So you typically use it in combination with a for statement. So let's just say I want it to count down from 10. I could do something like for x in range. Well, let's say I want to count up first. We'll do that one because that's an easier example. Okay, so for x in range 10, instead of printing it, let's actually check something regarding numbers, because when you're using range, you're usually using numbers. Okay, so it says for x in range. This is going to be a loop. It's basically the same thing as in Reborg when we did repeats. It's called for in Python. There's no such thing as repeat in actual regular syntax Python, so we use for instead of repeat. And we've got more options and more flexibility with it by using this range feature. So for x in range 10 is basically saying x is going to start at 0, and then every time we run the loop, x is going to go up by 1. So I can do whatever I want with x. It's going to be a number that changes. It's going to be an integer. It's not going to be a float. So if I wanted to do something like maybe print out all the even numbers, I might do something like this. So inside my loop, if x mod, sorry, I should do it the other way around. If x mod 2 is equal to 0, we know that if the remainder of x divided by 10 is 0, that it's an even number, because anything divided by 2 that doesn't have a remainder is an even number. So if that's the case, I can print it's even, and then I can also print whatever I want. You can have as many things running in here as you want at the same time. Just keep in mind, it's going to do it every single time it does the loop, because that's the whole point of a loop. It's going to repeat the process. So I could just print x here as well. In fact, I might even put it above that other print line just to show every time X changes, it's going to print what X is, and it's going to print it's even, or if it's not even, it has to be odd. So my else statement, I could put logic in here, another if statement saying if X mod 2 is equal to 1, then I could print it's odd, but I know if the number is not even, it must be odd. So I don't need to put any extra logic in here. I can just follow up with print X so we can see what it is, and then I'll print it's odd. So I'll step through this just to make it run a little slower so we can see what's happening on each step. So as I step through this, okay, so it gets to my first line. And if you mouse over X after it's past this line, it'll say X is 0. X is going to start at 0, and X is going to continually go up. Going up by 1 is the default until it gets to 10. But it's not actually going to hit 10. It's going to start at 0, and it's going to go to 9. So really, it stops 1 before whatever number you have in the brackets here, and you'll see how that works in a second. So we're running the loop for the first time. I mouse over X. You see X is an integer, and X is currently set to 0. So now it's going to check, is 0 divided by 2 equal to 0? It is. So it's going to print 0, which is, X is 0 right now, and then it's going to print it's even because it is an even number. In this case, is 0 really an even number? I don't know how the mathematicians figure about that, but if we do divide 0 divided by 2, it does equal 0 with no remainder. So it fits our logic for this case. Step through it. So now we're on the second loop. So now X has gone up by 1, right? So X is no longer 0. X is 1. Now it checks. It says, is 1 divided by 2 equal to 0? No, it isn't. Does it have a remainder of 0? No, it's got a remainder of 1, which means 1 must be an even number. So it prints X again, and it prints it's odd. Okay, so now it goes into the third iteration of the loop. So X is now going to be 2, right? Went with 0, then it was 1, and now it's 2. It's going to check. 2 divided by 2 is 1, and the remainder is 0. So it's going to run this line. So it's going to say 2, it's even. Now next time it's going to be 3, right? So if X is 3, this is going to be false, so it's going to skip down and do the else statement. It's going to say 3, it's odd, and it's just going to keep doing that. Keep running these one at a time, picking X up by 1 every time it runs the loop. And remember, because this stuff is all indented under the loop, it's running this every time we do the loop. We're up to 7 is odd, up to 8 is even. Now we're up to 9 now. So X is currently 9, which is an odd number, so it should print odd. And then you'll notice after that, it goes up here again, but it doesn't run 10. So after it's done the 9, it's done. You can see it's done down here in the lower corner. And what that means is you just have to be careful. Oops, 2, 3, 4, 5, 6, 7, 8, 9. When you're doing a loop, you just have to be aware that it's going to stop 1 before this. We want basically putting for X in range 10, we're saying we want this program to loop 10 times, but if it starts at 0, that counts, right? So if we count how many times this loop actually ran, because these are all the values that X was when I ran that program. If you count them, it'll add up to 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the 10th time the loop ran, X was actually 9 because computers start counting at 0. So that's just something to be aware of if you're running something. If you're running a program and using a range statement, remember that it's going to stop 1 before what you got here. Now, we don't have to start at 0. If you don't have anything before the 10 in your program here, it won't. It'll start at 0 if you only have 1 number in the brackets. If you put another number and a comma in the brackets, it's going to start there. So if I want to say, let's start at 3 and run until 9, I would just put 3, 10. So X is going to start out at 3, and then it's going to go to 4, 5, 6, 7, 8, 9, and then it's going to see 10 and stop. So it's not going to run it's not going to run when X equals 10. So our results will be a little different now because we're not starting at 0. We told it to start at 3 instead. So the first thing it should print out is 3 is odd, right? So it'll print out. I ran it all at once. So it printed 3 odd, 4 even, 5 odd, 6 even. I didn't step through it. I just ran the program. But you see everything in here makes sense, right? Instead of starting at 0, though, we started at 3. So we started at an odd number, even, odd, even, odd, even, and then we got to 9, and 9's odd. It sees 10 up here, and it doesn't run for X equals 10. So you can start at any number you want. You can end at any number you want. It doesn't matter. I mean, you'll eventually crash the computer if your number is in the millions or billions or whatever. But I just ran it to 99 here, and you see, well, right? So that's why loops are important, right? It would take me a long time to check all the numbers between 3 and 99 and write them down on a piece of paper, but computer can do it instantly, and it doesn't matter if it's 99 or 999 or 9,999. The computer does it almost instantly because they're really good at math. So there's going to be a lot of output here, but you'll see it got down to 9,998 is an even number, and I'm not going to scroll up through all of them, but you see that it runs it and it displays it pretty quickly. So using loops and knowing how to use range is pretty important. And then also, you have to know how to use a step value. So if you put a third number in the brackets, and let's just say I put 5 after this, that's the step value. And the default is if it's a positive number you have in the third position here in that statement, it's going to step up by that number every time. So it's going to start at 3, and then it's going to, it's going to check is 3 odd or even. It's going to say it's odd, and then it's going to add 5 to x. So instead of x being 4, it's going to skip ahead 5 more. So the next time it runs, it's going to be checking 8, and then it's going to be checking 13, and then it's going to be checking 18, etc. So if I'll just take this number back down to let's say 20 or something like that. We're going to check all the numbers, and we're just going to print odds or evens from 3, starting at 3, and then going to 8, and then going to 13. So we're skipping up by 5. We're adding 5 every time. So there's 3, it's odd. There's 8, it's even. Add 5, it's 13, it's odd. Add 5, it's 18, it's even. And then we try to add 5 to 18, we get 23. And 23 is higher than 20, so it's not going to run after that, right? So it's basically start, stop, and how much do you want to jump up by each time. And this last one's called the step value. You can also do it in reverse, just like we did list slicing and string slicing. You can go in reverse. You just got to remember to start with a higher number. So if I want to start at 20 and then stop at 2, I can do that. But if you're going backwards, you have to remember to change your step value to a negative number. So if I put in -3 here, it's going to start at 20 and it's going to check is 20 even or odd. Then it's going to go down by 3. So it's going to check 20, then it's going to check 17, then it's going to check 14, and it's going to stop when it gets to 4. So it's the same deal here. When it's going backwards, it's not actually going to run when x is equal to 3. It's going to stop at 4 because we're starting from a high number and then we're working our way left on the number line. So it's going to be 20, 17, 14, etc. When it gets to 4, that's the last time it'll run, because it'll eventually see that x equals 3, but it won't run it when x equals 3. So it's basically just the exact reverse of when you're stepping forward using numbers. So if I run this, okay, you'll notice it started at 20 because I told it to. That's the start and step. So 20 is even, 17 is odd, 14, 11, 8. It gets down to 5. It says 5 is odd, and then it subtracts 3 again. So 5 minus 3 is 2, and we notice that 2 is going to be lower than this value, so it's not going to run anymore, right? So it's just the exact opposite of running it forward and adding up. Now this time it's coming down, and you can change the step value to whatever you want. You can make it -6 or something like that. It's just how many times it's going to go up or down each time through the loop. And if you put it higher than the starting number, it's not going to. Or then, if you put it lower than the starting number, it's not going to run at all. So if I let's just say I put in no, I meant starting number. Sorry, not that. If you make a number bigger than this. So let's just say if I try to go down by 20, it's going to run the first time because it starts at 20 and it's going to say that's an even number. But then if I go 20 minus 20, I'll actually make this 25, just to make it a little bit more obvious. So it'll run on 20 and it'll say 20 is even, and then it'll try to subtract 25. But 20 minus 25 is -5, and -5 is lower than 3. So because we're going backwards, it's only going to run that one time. So it's going to say, hey, 20, it's even. Now I tried to subtract 25, so x is now equal to -2. I'm already past the point where I told it to stop, which means it's not going to go again. So just be aware of your step value. If it's not working the way that you expect it to, if it's not counting down or up by the number you expect it to, just make sure that you don't have a typo in your step value, and that should fix it up. Okay, so when I change the step value to -2, now I'm going down by 2 every time. So it says 20 is even, 18, 16, 14. These will all be even because I'm going down by 2. It gets to 4. It says 4 is even. Then it goes 4 subtract 2 is 2. And then 2 is already lower than that number, so it's not going to run again. So that's using range statements, using a step value and counting both forward and backward, okay, which is definitely on the exam. The string methods, this is review because we had this on the first exam already, and most people seem to have it. Let's just say I've got any string equals, hi there. And now you can adjust the string any way you want. Just be aware that unless you resave it in a variable, it's only going to display that way. So if I print s, obviously it's going to print hi there. Now let's say I print s dot upper. Okay, now it should print everything as uppercase, but keep in mind, because I didn't actually reassign it to a variable, it doesn't change the variable. It just changes. It doesn't change x. It just changes the way it looks for one line, and then it goes back to what it was. So this should print hi there, lowercase. This should print hi there, uppercase, and then this should print lowercase again, because the dot upper just was for display purposes one time. So when I run it, it says lowercase, uppercase, lowercase. Bigger, so it's a little easier to see. So in lowercase, uppercase, lowercase, because I didn't actually change what S was, I just changed the way it looked for a second. You can change the way that S both looks and is stored, but you have to restore it in the variable. So if I want to take S and permanently change it to uppercase, I would have to do S equals the old S, which is just S dot, and then change it to upper. So if I say S, the variable, is now going to store the old S in uppercase form. Now from the, whenever I print it or use it in the future, it's going to be uppercase because I restored it in the variable. If you don't restore it in the variable or a different variable, then it's just going to run that once. I resaved it in the S variable, but you very well could have made it a new variable called X. And so I didn't change the original S variable. I just reassigned what S was to a new variable called X. So now I would have two different options. The S would be the lowercase version and the X would be the uppercase version. So print the original, okay, and then I said X is equal to the uppercase version. Then I printed S again, so S was still lowercase, and then I printed X, and X was the uppercase because I made a new variable called X. And the same thing works with lower. We may not have specifically gone over starts with or ends with, but that's going to be a true or that's going to be a Boolean result. So if I print, oops, I'll keep my S here. If I print S dot starts with, and then I say, if I'm checking if it starts with H, which it does, this is actually going to print true. So this is just evaluating whether or not a string starts with whatever you want to check. So if I'm checking, does S start with H? It's not going to print H. It's going to print true because this thing is either true or false. It either starts with a lowercase h or it doesn't. So when I run this, it should just print true, and it does. Okay, and if I ask, does this start with S? It should print false because that string does not start with S. It starts with a lowercase h. Remember that case matters. So if I try to say, does it start with a capital H? It'll say false. It doesn't start with a capital H. So that's how you can use the start with, and I believe you can also do more than one character. So if I say starts with hi space, it should still say true. It does. It starts with HI and then there's a space. If I say, does it start with hi space X or D, sorry, this should be false because it does start with hi space, but then it's a T, not a D. So when I run this, it should be false. And the exact same logic for ends with. It's just looking at the end of the string instead. So ends with. Does this end with an E? Sure it does. A lowercase e. So that should be true. Does it end with TE? That should be false because clearly it doesn't. And then the other important string method is len. It's actually not a method technically, but it does operate a little differently. So if I want to find the length of this string, maybe I'll just say string length as a variable. And then if I want to find a number, how long is this string? It's not a dot notation. It's not dot len. It's len at the beginning, and then you put whatever you want to check the length of inside the bracket. So I want to check the length of whatever's stored in S. So that should be, remember, spaces count. So that should be 1, 2, 3, 4, 5, 6, 7, 8. That should be 8 characters. So hopefully it prints. Oops, I didn't print it. Print string length. String length, oops, is just a variable I made. It's not a special command. It's just a variable. So if I run this, it should print 8. I think I counted in there. Now, remember, it's counting, when you use len, it's counting the number of characters. It's not starting at 0 the way that index counts. It's not going to say how many characters are in this, 0, 1, 2. It's not going to do that. It's going to say, it's literally going to count how much stuff is in there, including spaces. So even though the index of the last letter, so if I want to print the index using string slicing, so if I want to print S7, okay, S7 is going to be the E, because H is 0, I is 1, space is 2, T is 3, 4, 5, 6, 7. So the E should be in the index position 7. So if I print S square bracket 7, it's just going to print the E, because that's in that position. But even though it's the last character, the length of this string is not 7, it's 8, because we start counting at 0 when we're dealing with string slicing. So even though the E is indeed the last character and it is indeed at place or index 7, it's not the length of the string. The string has 8 characters because we started counting at 0. So make sure you know how to use length. Make sure this is from a previous lesson, but make sure you understand how to do string splicing. I did that last, or string slicing, sorry. I did that last review session, so that you should have lots of information on that. The dot notation, if you hear that or read that, dot notation is just when you need a dot after your variable to access a built-in function like upper, like lower, like starts with, like ends with. Anything that you have to put a dot and then the function name in is it's called a method. You don't need to know that right now, but it's also referred to as dot notation, just because you have to have the period before you run it. Okay, so you need to know all looping structures. I went through 4 already. I went for something in something else. So we took care of those. For something in a list for X in range, that's actually a little complicated. You don't need to know that for the exam. For X in range with a positive or negative step value, we did that. That was the one that kind of looked like this. For X in range, starting at 3, ending at 10, jumping up by 2 each time. Or the reverse version of that would be starting at 10, ending at 3, and then going down by 2 each time, which would be a negative. So we went through that in pretty good detail. So that's all good. Let's get rid of all the other crap I have up here. While loops. Okay, so now for loops, this is the really important thing for remembering how to use loops. And it's the same as it was in Reborg, except instead of using repeat, we used for in Python. So you always use for loops when you know how many times to run. I'll say loop. And while, you use while loops when you don't know how many times. Okay, because a lot of times the user will control whether or not you want to run this particular loop again. You know, say for instance, type in yes to continue, type in no to stop the program. The user could want to run the program once, they could want to run it 100 times. They decide when the loop ends, and you don't know as a programmer how many times they're going to run it. So you have to build it in a flexible manner so that they can decide when it's done. And how we often do that is using something called a flag or a sentinel, and that's just a variable that's going to show you should you keep looping or not. There's a bunch of different ways to do this, but I typically just say flag equals. Let's say we want to have people typing in numbers until they type in -1, and we'll just print the numbers. So they can type in, they can run the program as many times as they want. They can loop it as many times as they want and tell us when they're done, when they want to type out the value -1. Okay, now this is an important concept here. Remember that anytime a user inputs something, it's by default going to be a string. Okay, so if you just want to print out the numbers they type in and you never have to do any math with them, it's fine to keep the numbers as a string. But remember when you're setting your flag, if -1 is the flag that tells us to stop looping, if you type in if flag equals -1, you've actually set your flag to an integer, right? So that's an integer, -1. So if you're not going to change if you're not going to cast the input to a new data type, if you're not going to make it into an integer or a float, you got to make sure that you're checking for a string. Okay, so -1 with quotes is a string. It looks like an integer, but because I've got the quotes, it's a string. So when I build my while loop, so I'm going to say while flag not equal Okay, well, if the flag is not equal to -1, actually, I'm not going to set my flag to -1. I'm going to set it to -2 because I want it to run at least once, right? So I can set it to anything, just not -1. So while the flag is not equal to, and remember, we've got to make sure that we're doing this as a string. Okay, so while the flag is not equal to -1, I'm going to run my program. So the flag not equal to -1, I said I was going to get them to enter a number, and then I'm just going to print the number. And when they type in -1, the loop should end. So let's get our input. Let's just say whatever, user input variable, right, equals input, and then type in number, type -1 to end. Okay, so I've given them some input, or I've given them a prompt saying what I want them to do, and then what I'm going to do is in here is just a quick if statement. If user input, that's the variable, is not equal to 1, so, or -1, so that would be not equal to, and then I got to do a string again, right? -1. If it's not equal to -1, I want to print it. So print user input, and then I don't need another brackets. I don't need an else statement because my loop's going to catch it. So this is the way that this is going to run. I'll step through it slowly just to make sure that we understand what's going on here. Okay, so the first thing it's going to do is going to set a flag, just a variable, and it's going to be setting it to it's not an integer. I just forgot to erase that. This is actually a string because I got quotes. So it's setting a flag equal to the string or word -2. Now it's going to go to my loop and it's going to say while whatever is stored in flag is not equal to -1, it's going to keep doing everything underneath it. So currently our flag is not equal to -1, it's equal to -2, which means this is true. The flag is not equal to -1. So if the top while part is true, it's going to run whatever's underneath it. So it should say input, and it's going to give you the prompt, enter a number, type -1 to end. Well, I want it to loop at least once, so maybe I'll put in the number 65. That is okay. Now it's going to check, is the user input, so I typed in 65, is the user input not equal to -1? That is true. I typed in 65, so 65 is not equal to -1. So we know with if statements, if this is true, then it's going to do what's underneath it, which means it's going to print the number. So it prints the number, print 65. Now it goes back up and checks, do I need to loop again? And it checks the exact same thing. Is the flag equal to or not equal to -1? It's currently still 65. That's the last thing I typed in. So this is still true. It's not equal to -1, which means it's going to loop again. Let's say I want to type in another number here. Let's type in 87. To run the same check, is 87 not equal to -1? That is true. It is not equal to -1, so it's going to print the user input. It's going to print 87. Okay, now it's going back up again, running the same check on the while statement. Is flag not equal to -2? I just noticed a mistake I made, and you'll see how it happens right here. So is flag not equal to -1? It is not equal to -1. It's still equal to 87. So it's going to ask me for another number. Now here's where I made an error. So I'm going to type in -1 because I want to end the program, and you'll see the error right away, the error that I made. If user input is not equal to -1. Now this becomes false because I did type in -1. So user input is now equal to 1, which means this statement's false, which means it's not going to print it. Here's the mistake I made. It's going to go back up to the loop and check the flag again. But you'll notice that the flag is still -2, and you also notice that the flag never changed. The reason the flag never changed, I've actually made a program that will never end here because I never actually changed the flag anywhere. Okay, so the way that I should have done this, which would have made more sense, the mistake I made is I set a new variable here, and I checked the use variable to see whether I print or not, but I never actually changed the flag. So there's a couple ways that I can fix this, because if the flag never changes, it's just going to keep running because the flag is never going to be equal to -1, which means it's just going to keep looping forever. So there are a couple ways that I could fix this. I could just not use user input, and I could just make that my flag. So this is the same flag the entire way through. It starts at -2. I check, is -2 not equal to -1? And then down here, I can change it. So this is all the same variable. So if they do end up typing -1, it will actually change the flag instead of that user input variable. So if I change all the user input variables to the flag variable, now this will work properly. Okay, so I'll just run it. The first time I run it, I want to type a 4. Great. I want to type a 7. Now if I type -1, I'm actually changing what's stored in the flag variable. So when it goes up and checks in, it checks. Maybe I should include another line down at the bottom just so that we know that our program actually ended. So print program ended, just to make sure we're getting to the end of the program. Okay, so I'll run it again here. Type in a number 56, type in a number 6, type in a number -1. This should end the program, and it does. You see where it says program ended. So that was sort of an easy way to change it, is just making sure that the I changed the flag using the input. Another way I could have done it, if I wanted to keep this as a separate, if I wanted to use this as a separate variable for whatever reason, if I want to include or continue using user input, this is just basically putting it back to the way it was before. Okay. If I wanted to continue using the user input variable that I create here, it's not a big deal. All you need to do is now you do need to include an else, because if the user input is not equal to -1, you want to print it. But if it is equal to -1, what you actually want to do is you want to set your flag to -1 so that you've changed the flag so that when it comes up to the while loop again, it'll actually have a different value for flag. Before, I just had user input. I never actually changed the flag anywhere inside the loop, which means if the flag never changes, it's never going to stop looping. So now I have two variables. I have a user input variable that I use to check whether or not I should print it. And if I don't print it because they typed in a -1, then I'm changing the flag to be -1. So the next time it comes up to the loop, it says, oh, I shouldn't run anymore. So that's two different ways of fixing the same problem. So type in a number, 460, 56, type in a number, 8, type in a number, 3, type in a number, -1, and then you'll notice my program ended because I had this else statement in there telling the program they want to stop, the user wants to stop, so make sure you set the flag equal to -1 and then run it. Okay, now I said that if you're just printing out numbers and you don't have to use them for math or anything, you can keep them as a string. But what happens if you do need to use the number and actually print something, or sorry, do some math with it? Now it makes more sense for our flag to be an actual integer. So I'm going to say flag is equal to -1 this time, not the string, but the actual integer -1. So it is now an integer. And I'm going to check the same way. So if flag is not equal to -1, now I had to change this because now I'm checking if the flag is, not equal to -1. Now this is an integer. I'm checking with an integer, not with a string. Okay, now let's say I need to get input that I'm going to use for math. So let's say type in a number, type -1 to end is still fine. Okay, so this is all just a string because it's just the prompt. It's just telling the user what to do. However, because I want to do some math, let's say I want to if they type in a number that's not -1, let's say I want to print that number times 2. Okay, if I want to print something times 2 and I want to get the right numerical answer, I need to make sure that I'm multiplying numbers, either floats or integers. I'll just use integers. Okay, so I need to change all of these things from strings to integers. So let's just run through this in my head here. While the flag is not equal to -1, I should make that -2 because I want it to run at least once. While the flag is not equal to -1, I'm going to get the user to input a number. Type in a number, type -1 to end. Remember that input by default is a string. So if you want to take whatever they enter and make it into an integer, you have to cast it as an integer. So that means putting int out front of your input statement. Okay, so that whatever they type in, it's going to turn it into an integer. Remember, these always run from the inside out. So it's going to run the input statement first to get whatever they want to type in, and then it's going to change whatever they type in to an integer. Okay. Now I'm going to use a check. If the user input is not equal to -1, print the user input times 2. So I said I wanted to print whatever it was times 2. So if they type in 2, it's going to print 4. They type in 8, it's going to print 16. Okay, if it's not -1, then it's going to run the else. And I'll say, make my flag -1, so that when it goes up here to check, it's going to check, is the integer -1 not equal to the integer -1? Okay, so make sure that you're using the proper data type when you're checking your flag. We'll run through this step by step just to make sure it's working the way we think it should be working. So F7, set my flag to -2. Okay, so now when I mouse over my flag, you see it's an integer, it's -2. Now it's checking, is the flag not equal to -1? This should evaluate to true because -2 is not equal to -1. That makes this true, which means it's going to run. So the first thing inside the loop is get user input. So I'm going to get a user input. It's going to ask me for a number. I'm going to type in 65. And even though it starts out as a string, it's going to change it into an integer because I told it to. So it's going to change that 65 into an integer. So now if I mouse over my user input variable, you'll see it says integer 65. Now it's going to check, is 65 not equal to -1? That is true. 65 is not equal to -1, which means it's going to run the if part. So it's going to print 65 times 2, it should print 130. Okay, now it goes back up to the loop and it says, is -2, okay, is -2 equal to -1? Well, you'll notice I made the exact, no, I didn't actually, no, I didn't make the exact same mistake, it's fine. My flag is still currently -2 because I never changed it. So this is still true, which means it's going to run again. So this time I'll type in something different. I'll type in 3. So it should print out 6, right? Because user input 3 is not equal to -1, so that's true. So it's going to print 3 times 2 is 6. Then it's going to go loop again. Okay, now this time I'll say I want it to end. All right, so I'm going to input -1 this time, which is my key, which is my flag to say I'm done I've done typing stuff in. I don't want to run anymore. So you'll notice user input is -1, and when it runs this if statement, now this should be false. -1 is -1 not equal to -1? That's false. So now that this is false, it's going to do the else instead of the if, which means it's going to change the flag to -1. And now when it checks again, you notice I changed the flag. The flag is now an integer worth -1. Now this is going to be false. So is the flag not equal to -1? That is now false. The flag is equal to -1 now, which means this whole while statement is false, which means it's not going to run it. It's not going to loop it anymore, which means it's just going to go down to the next available line, which is print program ended. Okay, so the whole point of that is you can use integers, you can use floats, you can use Boolean, you can use strings, you can use any data type for your flags. Just make sure that your data types match up and that you're not trying to compare a string and an integer, or you can compare an integer and a float because they're both kind of numbers. But if you're trying to compare strings to them or Boolean to them, you're going to run into trouble and you're going to say, oh, they typed in -1. Why won't my program end? It's probably because they typed in -1 and you never changed it to an integer. So it's checking to see if basically if the word -1 is the same as the number -1, and it isn't, right? So that it's an error that's called a semantic error or a logic error. It's not, you didn't do anything wrong in your program to make it break. So it'll run every time, it'll run properly, but it won't give you the results you want because you made an error. And those are the toughest errors to track down because you don't actually get an error from the computer saying, hey, you screwed this thing up. It runs, it just doesn't do what you want it to do. All right, so not and or. I went through this a bit before in the last one. Remember I always say neo. That's how I remember the order of operations. It's just like remembering BEDMAS or PEDMAS or PEMDAS or whatever you do for your math operations. Parentheses, exponents, division, multiplication in order, addition, subtraction in order. Not and or work the same way in computer science. So you need to do them in the proper order. Otherwise, you might not get the result you want. So if I want to print the result of, let's just say print not true or false or not false. So I'm printing the result of whatever's in the brackets. It's just like math. You need to use the neo to do the order of operations. And technically, even in front of the neo, I might even put a B, neo, neo. However you want to remember it is up to you. But it'll do brackets before it does anything else. And then if there's no brackets, then it'll revert to NAO. So I guess technically it's BNAO. So if we look at this, what I'm going to print here it's going to start with the brackets. So these outside brackets, that's just for the print statement. So those ones don't count. But inside the print statements, I've got these in brackets. So it's going to do this part first. True or false? Well, we know from our logic tables that true or false should evaluate to true. Okay, so now we've gotten rid of the brackets. So what we're left with after it runs the first kind of check, what we're left with is not, and then true or false evaluated to true. So basically we're at not true, and we didn't do anything with the last part, so it's not true or not false. Okay, so that's what we're left with. Okay, what's the next thing it's going to do? I've got a not, an or, that's it. So I've only got a not or an or. It's going to do the nots first. So it's going to do not true. Okay, so not true is false. So it's at the front, it's going to be false. And then I didn't do anything with the or. And then not false at the end, because I have to do that before the or, is going to be true. So not false is true. So now I'm left with false or true. And false or true should evaluate to true. So if we've interpreted this correctly, the final result of printing this should print true. Okay, and it does, which means we did it properly. I don't have an and in here, so let's put or, not false, and false. And let's just see if this changes things any. Okay, so I've got an and in there now as well. So it's going to do the same order of operations. It's going to find out that this is true or false is true. So it's going to be not true or not false, and false would be left over after the first check. Then after that, we've got nots, we've got ors, and we've got ands. So we know it's going to do the nots first. So we're going to have not true is false, or not false is true. So we've got F or T, and then we'll do the and false at the end because we didn't do anything with that. Okay, so there's another step in this one because I added a not, right? I added a not false, so there's one more step. It's doing all this instantly behind the scenes. I just want to show you what the computer is doing in the order that it's doing it. So I've got an or and an and left. It's going to do the or first. So it's going to do false or true, which is going to lead to true. And then it's got and false. So basically I'm left with true and false. And we know that true and false is actually going to evaluate to false, okay? Because both of these have to be correct, or both of these have to be true in order for it to be true. So this time our result should actually be false. And it is, which means we've done our order of operations correctly. So that's just order of operations. Basically, if you remember this part, or if you can find it in your notes, you shouldn't have any trouble with those questions. Random integers and math functions, we've done this already in the first exam. I don't think I'm going to do it again. Just remember, if you're doing anything that's random or math related, you have to import those libraries. So this would be from random import. And I usually just do star. Just import everything from the random library. And then you'd also have to do it from the math library, which is a different file, right? So form math, import star. Now I've got access to all of the math, built-in math functions and all the built-in random functions. So if I want to do a random number, let's between 1 and 10, I can say a equals rand int, and then 1 to 10. So that'll get a random number between 1 and 10. Some people were getting errors because they were doing this, random dot rand int. You don't have to do that because you've already imported the random, which means as soon as you've imported the random or the math or whatever else you're importing, you don't need that part anymore. You just need the actual, built-in function that you're using. And then let's use a math import. Let's use the power, right? We know how we can do a power just using the double asterisk, but let's say b equals a, which is a random integer, and then let's do a power of, and then it's going to be x to the power of y in the bracket. So we want to do a to the power of 2. So what this will do, oops, not 22. Now I'll print b. So what this is going to do is it's going to basically import all this built-in functions from random and math. It got me a random number between 1 and 10, and then it's going to find the power. So it's going to find whatever that number is to the power of 2, and then it's going to print it out because it's stored in b. So it obviously, my random number was 7 because it printed out 49. 7 squared is 49. If I change this, let's say I change this to the power of 3, and I'll just make it a random number between 1 and 4 and run it. Now it'll do whatever that number is to the power of 3. So obviously the random number I picked this time was 3 because 3 to the power of 3 is 27. If I run it again, now I got 8, which means that the random number was 2 this time because 2 to the power of 3 is 8. So that's the process you have to go through when you're importing and using math and random functions. we went through slicing of strings and identifying index position, went through all that in the last section. We went through list operations as well. Lists and strings are really closely related to each other because pretty much whatever you can do to a string, you can also do to a list. So if I have a string, s equals hello, and then I have a list, let's just call it, whatever, list, temp list or something like that, equals, and then I'll just put a bunch of different data types. I'll put an integer, I'll put a float, I'll put a word, hello, I'll put true, I'll put another 6.8, I'll put another float. You can store whatever you want inside a list, including other lists, right? I can put more brackets than I can put 1, 2, 3. That's a list in itself because it's square bracket, and then whatever I wanted to have in that list, and then another square bracket, and I can have whatever I want in a list. So this is just basically a container inside a container, and it's all inside the big temp list container. Whatever I do with a string, I can do with a list, more or less. So if I want to print out the first element of, the first index of the word hello in that S, I can print S and then square bracket 0, which we know is going to be the first letter in this word. I can do the exact same thing with a list. So if I print temp list and then square bracket 0, it's just going to print out what the first thing in the list is, which is 5. Okay, so it'll print out H, and then it prints out 5. If I want to print out the last thing in the list, I can in the string, I can use -1, and I can do the same thing with temporary list. So now it's going to print the last letter in S, which is O, and it's going to print the last thing in the list. Now, the last thing in my list is actually this whole list that I had inside here. So it's actually going to print the list 1, high, 3. If I put something after that, let's just say I put true after that. Now true is the last thing in my list, in my big list, so it'll print true instead. If I change it again and I put a 4 in there, it's going to print 4 as the last thing. And the slicing works exactly the same. If I want to print the first 3 letters, HEL, I can use blank and then colon, and then I want it to start up at 3. Okay, because this is 0, the E is 1, and the first L is 2. And remember, it stops as soon as it gets to the third thing. So if I print out the same thing with the list, remember, if I've got a colon and nothing in front of it, it means I'm going to start at the start. So if I go to index 3 in the list, it's going to print the 0th element, which is 5. It's going to print the 1 element, which is 4.6, and it's going to print the 2 element, which is hello. So it works it's not printing the same thing, but it works the same way, right? I can print the first 3 letters of this, or I can print the first 3 items in my list. And then I can also use step value as well. If I want to skip up by 2 each time, I can put another colon, okay, and I can skip up by 2 each time. So this time I want to start at, let's just go to the very end of the list, which is going to be either -1, or I can just leave it blank, right? So I've got blank, which means I start at the start, and then a colon, and then blank, which means I end at the end, which is going to be the O, and I want to jump up by 2 each time. So I'm going to print the H, then I'm going to skip over the E to the L, then I'm going to skip over the other L to the O. List will work the exact same way. So if I have blank colon 2, it's going to start with the first element here, which is a 5. It's going to skip over the 4.6, print the hello, skip over the true, and it's just going to be printing basically every second thing. So here it's printed HLO, so it's skipped over. And here it printed 5, then skipped, hello, skipped, 6.8, skipped, true. Okay. And you can go backwards as well. Just remember to have the high number first, right? So I'm going to start at the B, let's just say I'm going to start at item 5, and I'm going to end at item 1, and then I'm going to go down by 1 each time. So that's basically my starting point is nearer to the end of the list or to the end of the word. I am going to stop before I hit the H, and I'm going to go down by 1 each time. So I can do the exact same thing with my list, 5 to 1, skipping, going down by 1 each time. So it's going to start at the 5th element, which is 0, 1, 2, 3, 4, 5. I'm actually going to change this. I'm just going to make these regular list items. So it's, what do I got here? 0, 1, 2, 3, 4, 5. So it's going to start at the 1 because that's the 5th position in the list. And it's going to stop before it hits the 5. So actually 4.6 is the last thing it's going to print. And because I've got a negative number, it's going to be going down. So it should print high, or did I say 1 was where it started? Yeah, it's going to print 1, 6.8, true, hello, 4.6, and then it's going to stop. The string is going to start at the 5th index as well. So it's H is 0, 1, 2, 3, 4. 5 is actually outside of the list, so maybe I should change this to 3. I'll change this to 3 as well. So we'll start at the third item, which is 0, 1, 2, 3. So it starts at the second L, and then it stops at 1. So when I print that, I've got LL. So it printed that, it printed that, and it didn't print the E because E is 1, right? The index 1. Remember, it's the index position, not the number of characters. So if E is 1, I told it to stop at 1, which means as soon as it saw that it was at the index position 1, it stopped right away. Okay, so that's how you do slicing with lists, removing, sorting, all that stuff from lists you should have lots of practice with, so that should be fine. Sorting lists, there's lots of information, and split there is as well, so I'm actually not worried about that at all. That was pretty quick, but the videos that are included in Module 4 and the other review videos that I put up have lots of in-depth information and probably go through that a lot of that stuff slightly slower. This was just a quick review to show you how to use all of those things, which is everything you need to know for the second unit exam. So best of luck. I'm late for a communications media live session, but as always, if you have any questions with any of the remaining assignments, let me know. If you don't understand a question on the exam, you can ask me to try to maybe phrase it in a different way, but I can't answer the question for you, right? It's supposed to be a test of your knowledge. But I think most of them are worded in a relatively straightforward manner. Make sure you read the questions carefully. Make sure that whatever code you build is going to give you the input or the output that I have on the exam. So I tell you what it should look like if you've done it properly. Make sure yours matches that. And the same thing in the practical. I've got it formatted in a certain way. Make sure your format for whatever prints out is as close to what I have as possible. So best of luck. I'll see you again on Thursday, and hopefully you have great success meeting your goals in the next week. Take care. You bet. See you later.